All right, folks. Well, welcome back. I hope everyone had a chance to get some rest over the break, step away from school and TV screens and screens in general, and hopefully get some things done around the house that doesn't involve screens. But now that we're back and we're still doing the distance learning, what I would like to do then is I would like to go ahead and review with you what we've done so far. Remember, we finished up with chapter 10 already, and we did start chapter 12. And I had mentioned to you prior to break that we will be doing we'll be taking the exam. And let me go ahead and get started. Yeah. We'll be taking the exam this week. And so the exam will be this Friday. We'll take the chapter 10 exam this Friday. What I'd like to do on tomorrow, and I'll make note of this on Classroom. I'd like us to meet during our class period, so that's between 12:05 and 12:45. I'd like to meet with you to give you an idea of what we will be doing in terms of the exam, the format of the exam, how we'll be doing it. And so tomorrow, in place of a lecture video, I would like us to meet on Zoom, and I'll post the link for you on Classroom. I'd like to meet on Zoom. For the Edmodo folks, if you have not logged on yet and you haven't registered, please make sure you do so. That will be the platform that we're going to use in order to do exams and quizzes. And so make sure you, before tomorrow, make sure you log on and register through Edmodo. And then I'll walk you through tomorrow. I'll walk you through the process by which we're going to use to take the exam on Friday. And then on Thursday, what we'll do then is we'll have a review. We'll have a review for the exam on Friday. And the format will be fairly similar to what we do in class. On Thursday, we will also meet live through Zoom, and I will take your questions at that time on Chapter 10 of the Chapter 10 material, and we'll review at that time for the exam on Friday. Okay, so tomorrow we will meet live on Zoom at during our regular class period, 12:05 to 12:45, so I can walk you through how we will you will take the exam. And then on Thursday, we will meet live again so that we can review for the exam on Friday. All right, so that's the schedule for this week moving forward. Hopefully, if you have any questions, like I said, you can ask either tomorrow or Thursday. But if you have a pressing issue or a question you need to ask today, I will be available for office hours from 1:30 to 2:30 today. So stop on by through Zoom and get your questions answered then as well. Okay. All right, so that's where we are headed this week moving forward. What I'd like us to do then is let's get started. Let's take a look at, so this is the number 4 from the chapter 12 problem set. This will allow us to practice what we have done in chapter 10, and this will give you some idea of what you'll need to review for the chapter 10 exam on Friday, or what you may need to ask about when we review this on Thursday. But like I said, if you if you'd like to get the questions answered prior to then stop by after school today, 1:30 to 2:30 to get that question answered. So what I would like to do to start out the period this morning, this afternoon, is I want you to get this problem done. Okay, make sure you write out do your work on the paper, on your paper for submission, and then make sure you type your answers on Edpuzzle as well. Okay, so let's take about 5 minutes, roughly 5 minutes or so, to get these 4 calculations done. And then when we get back, I'll work out these problems for you. And this will give us a chance to review the material we covered in chapter 10 and what you will see on the exam on Friday. Okay. All right. So take about 5 minutes to get these 4 calculations done. Okay. All right. Hopefully everyone had a chance to get these problems done. Let's go ahead then and let's work through these problems together. And then that way then we can review what you'll need to do in order to get this prepared for the exam on Friday. Okay. All right. So in chapter 10, we learned about quantities. We learned about how we can describe how much of a given substance that we have. Okay, so remember, everything in the universe has mass, it takes up space, it has volume. And there's a certain number of each of the objects that we have in the universe. We can count out those individual objects. And so with that said, then we learned about this unit mole that describes objects, the number of objects in that unit mole. And we've talked about this. And unit mole, so 1 mole of a substance, is equal to this number, 6.02 times 10 to the 23rd. Okay? And so this unit here is the central unit. This is the key unit to understanding what we will be doing in what we did in chapter 10 and what we will be doing in chapter 12. Okay? And so this unit, this term mole represents then this many objects. So for example, we have 1 mole of iron atoms. We would have then exactly 6.02 times 10 to the 23rd iron atoms. Okay. So the unit mole just represents then a number of a certain object. Okay. This is akin to saying 1 dozen, for example. So we have 1 dozen. The unit here is dozen. That term dozen equals this exact number here, this number 12. So if you have a dozen eggs, for example, you have 12 eggs. So we had 1 dozen iron atoms. That would be equivalent to equal to 12 iron atoms. Now, we don't usually talk about a dozen iron atoms because iron atoms are so small. And so this unit mole, then, what we use it for is to allow us to discuss quantities of these very small objects. We can discuss them in terms of a larger macroscopic amount. So we can obtain the amount of 1 iron atom here. And so we were able to, so if you take 1 mole of iron atoms, for example, and again, if we scale it up, okay, that's going to be equal to this many atoms of iron. Okay, so that's going to be 6.02 times 10 to the 23rd atoms of iron. Okay. And this number of atoms is on the macroscopic scale. That's on the real world scale here, because if you take this many iron atoms and you weigh them out, and if you weigh them out, it will be equal to 56 grams. Okay? And so this number here we can measure. We can get that and we can obtain that amount of iron. If you cannot measure out 12 iron atoms because the mass of those 12 iron atoms would be so small, we wouldn't be able to get that. Okay? And so this unit mole then allows us to talk about a very large number of these small objects, but with this amount of these small objects, we get this mass here. So the relationship that we're dealing with here is 1 mole of iron atoms is equal to this mass here, 56 grams of iron. Okay? This is what we refer to then as the molar mass. We learned about the molar mass back in chapter 10. The molar mass then is the mass of 1 mole of a particular object. And the molar mass of an element, like we have here, the molar mass of an element here, we can obtain that directly from the periodic table. Okay? And so remember, from the periodic table, we have the mass number and the atomic number. The atomic number gives us the number of protons and the neutral atom electrons. But we also have the mass number. The mass number gave us the mass of one atom of that particular isotope, the mass of 1 atom of that particular isotope of that atom. However, we can also use that number to describe then the molar mass, which is the mass of this many atoms of that particular atom. Okay? So for example, then, the atomic mass of 1 atom of iron is going to be 56 AMUs, atomic mass units. However, if we have this number here, which is, we also give a name since this number comes up so often, we talk about Avogadro's number. We have Avogadro's number of iron atoms. It is going to have a mass of 56 grams. Okay, so that's the nice thing about what we do here in science and in chemistry, is that there are these repeatable patterns that will come up again. Okay? All right, so that's our molar mass. So the molar mass then is defined then as the mass of 1 mole of an atom. Okay, so we learned about the unit mole in chapter 10. We talked about the molar mass in chapter 10 as well. And then we talked about how if we have 1 mole of iron, and let's say we vaporized iron, we made it into a gas. And so we have then 1 mole of iron gas. The gas iron, not iron atoms. Okay? If we have 1 mole of iron in the vapor state, okay, we can determine then the volume, the amount of space that 1 mole, which is going to be equal to 6.02 times 10 to the 23rd iron atoms in the gaseous state. Okay, that's going to be equal to 22.4 liters. Okay, this, and remember, this only works when the conditions are at STP. STP then meaning the temperature. T is for temperature, 0 degrees Celsius. P is for pressure, which is the atmospheric pressure, which is 1 atmosphere. So under the conditions of STP, 0 degrees, 1 atmosphere, any gas. So we take we take our iron, we melt it, and then we vaporize it. We heat it up to the point where it becomes vapor. And we take this amount of iron atoms that are in the gaseous state here, and we determine the volume occupied by that particular this many iron atoms in the gaseous state. It will be 22.4, and it will always be 22.4 as long as the gas. Okay, so this is going to be iron gas. We take iron and we make it into the gaseous state, iron in the gaseous state. Okay, then we get this volume. This is what we refer to as the molar volume. Okay, and this molar volume then is the volume occupied by 1 mole of a gas. And it doesn't matter the identity of the gas. It doesn't matter what the identity of the gas is. It could be iron in the gas state. It could be oxygen, hydrogen, helium. Doesn't matter as long as it's a gas. And if we have 1 mole of that gas, if the temperature is at 0 degrees Celsius and the pressure is at 1 atmosphere, then this will always be true. That the volume will always be 22.4 liters when you have 1 mole of that gas. Okay? And so we talked about those 3 conversion factors. We learned about them in chapter 10. And so make sure you understand then that what we did then is in chapter 10, we did these conversions. So if we started out with less than a mole or more than a mole of iron, we should be able to determine then the number of iron atoms that are equivalent to whatever moles we have here. Okay? We can determine then the mass of the iron atoms for however many moles we have here. So, and same thing with the molar the volume here. So if you change the number of moles of the gas, of the substance we have, we should be able to calculate for the number of particles equivalent to it, the mass that's equivalent to it, and the volume that's equivalent to that change as well. Okay. All right, so make sure you keep this in mind. Make sure you write this down if you haven't done this yet. So we talked about the unit mole, we talked about the molar mass, and we talked about the molar volume. So these are 3 key concepts that you need to make sure you review in order to do well on the exam on Friday. Okay, so review those. Okay, but before we but make sure you understand then that when you do these, okay, when we do these problems here, these problems will allow us to work out and practice this. Okay, so let's take a look at the very first problem in number 4. The first calculation you have to do in number 4. Go ahead. Quickly use the blue pen here. Okay, all right. So for the very first one, what they're asking us to do here is they're asking us to find the number of moles equivalent to it. So here you start out with a given quantity, either in terms of volume or in terms of mass or in terms of particles, and we're asked to find the moles. Okay? And so we're using the relationship between moles in each one of these in order to get that done. So this is a conversion. And as conversion, remember, there's always 3 questions that you have to make sure you ask yourself to do the conversion. And that is, what do you start out with? What do you want to solve for, and what will be the conversion factor that you use? Okay. All right. So for the very first one, what do we start out with? That is, what do they give us? They give us the volume. So 54.0 liters of this gas here, okay, of NO2, and nitrogen dioxide is going to be a gas. So in the very first calculation that we're going to do in number 4, that's we start out with. Okay. What we're solving for then is the number of moles equivalent to that volume. Okay. So moles of NO2, right? And so the question now is, and the conditions then are at STP, and that's going to be critical for you to remember. Okay, STP. Okay. All right. So with that said, then what is the conversion factor? The conversion factor is the value that relates this unit here to this unit here. Okay, and do we know what the relationship is between volume of a gas and the moles of a gas? And the answer is yes, we do. It's what we refer to then as the molar volume, and we talked about that, the molar volume. Okay? And the molar volume then describes the relationship as 1 mole of a gas is going to be equal to 22.4 liters, meaning then whenever you have 1 mole of any gas, doesn't matter what the gas is, 1 mole of that gas is going to occupy this volume of space. Okay, and so it just happens to be that the volume, the gas in this problem here is nitrogen dioxide gas. But again, the identity doesn't matter. It's this relationship here. So as long as we have 1 mole, okay, we will occupy this amount of space. Okay, so going back to this problem then, okay, you notice here we don't have 22.4 liters. We have more than 22.4 liters, which means that we're going to have more than 1 mole of nitrogen dioxide gas. Because this here gives us the relationship between 1 mole of the gas and its volume it's occupied. Okay, so this is the conversion factor we're going to use. Now, how do we use the conversion factor to determine the number of moles? Well, we want to set this up in such a manner where the starting unit cancels out, and we end up with moles on both sides of the arrow. Okay, so how do we do that? Well, if we place moles on top, and I'm going to go ahead here and plug in the gas itself, moles of nitrogen dioxide gas, okay, and we put the volume on the bottom, 22.4 liters of nitrogen dioxide gas. If you set it up this way, where it's 1 mole over, so 1 mole over 22.4 liters, the unit of liter cancels out. We end up with moles on both sides of the arrow, which means then we plugged in our conversion factor correctly. So the third question, that is, what is the conversion factor? You have to be able to identify the relationship between the unit that you start out with and the unit that you want to end up with. Okay? And in this particular problem, that relationship is this molar volume that we talked about in chapter 10. Okay? All right, at this point, then it's just a matter of you being able to plug these numbers into your calculator to be able to answer the to obtain an answer here, and the answer you obtain then is 2.41 moles. Okay, and that's your answer to 3 significant figures. Okay, all right, very good. Let's go ahead and let's take a look at the second problem. Then let's go ahead and work these remaining problems out. Okay, all right. So question number 1, it's a conversion. So we are told then that we have 1 point. We're starting out with 1.68 grams of magnesium ions. So the magnesium ions, that is the object, the substance that we're dealing with. Okay, and we're going to solve then for moles, and I'm going to abbreviate here as moles of magnesium ions as well. So that's the conversion that we're doing. This is what we start out with. This is what we're going to solve for. And so again, what's the relationship between this unit and this unit here? Well, the answer then is going to be the molar mass. Okay, the molar mass. And so the molar mass then is going to be for magnesium then 1 mole of magnesium. And here in magnesium ion, it doesn't really matter that it's in the magnesium ion. It's the atom of magnesium that's lost 2 electrons. And we learned back in chapter 5, back in chapter 7, that the electron doesn't have that much mass. So if you lose 2 electrons here, the mass of the magnesium ion is going to be equal to the mass of the neutral magnesium. That's going to be 24 grams of magnesium ion. Okay, and so where do we get this molar mass from? We get it from the periodic table. Okay, the atom here is magnesium, so we just find then in the periodic table, find magnesium in the periodic table, and get our molar mass here. So the molar mass describes for us the relationship between moles, 1 mole of a substance, and the mass of that substance. In this case, it's going to be the ion magnesium, the magnesium ion. Okay? All right, so let's go ahead and plug it in. So how do we plug it in? Let's plug it in so that moles, 1 mole of magnesium is on top, and 24 grams of magnesium is on the bottom. Why do we want to plug in that way? So that the unit grams of magnesium cancels out. We end up with moles of magnesium on both sides. We did the conversion correctly. Plugging these numbers into our calculator, then we end up with an answer of 7.00 moles of magnesium. Okay, so again, we start out here then with I'm sorry, times 10 to the minus 2. Sorry, guys. So hold on, let me go ahead and do this. That I knew that didn't look right. Okay. Okay. So this is going to be 7.00 times 10 to the minus 2 moles of magnesium. So here we obviously have less than 24 grams of magnesium ions. So therefore we expect then that we should have less than 1 mole of magnesium ion as well. So that is the conversion that we're doing. So we're trying to find the equivalent amount of moles of magnesium with this mass of magnesium. Okay. All right, let's go ahead and do the remaining 2. And then, like I said, you can combine and see me if you have any questions about this. Okay, so for the third one, we start out with 69.6 grams. Okay, this time then of sodium hypochlorite. Okay, for these problems here, folks, and I've been emphasizing this point since day 1 of our class, you have to be able to obtain the right formulas. Okay, you have to know how to do this. Okay, so for the third one, then they tell us that we have a mass of this particular compound. Unlike number 2, where it's just an element, it's just a single element in its ionic state. With number 3, the third calculation we have to do, we have a compound. Okay? And the compound is sodium hypochlorite. So you have to be able to come up with the correct formula for this compound. Why? Because we're going to use the molar mass again, because we have grams of sodium hypochlorite here. They want us to find the moles of sodium hypochlorite. Okay, so this is a grams to moles conversion. Okay, so this is what we start out with. This is what we're going to solve for. And so the conversion factor that we're going to use here again is the molar mass. Okay. However, with this molar mass here, since this is the molar mass of a compound, we need to add together the molar masses of each one of these atoms here. And the only way you're going to get the correct molar mass for this compound is by getting the correct formula. Why do you need the correct formula? Because the correct formula gives us the ratio of each one of the atoms in this compound. If you get the wrong formula, you get the wrong ratio. You get the wrong ratio, you're going to add the wrong numbers together, and you're going to get the wrong molar mass. Okay, so sodium hypochlorite is an ionic compound with sodium as your cation. The anion here is the hypochlorite anion. That's one of the polyatomic anions which you had to memorize. So make sure you go back and you memorize, review those for the exam on Friday. But this is going to be our molar mass. Okay, so if you add together 1 sodium, 1 chlorine, 1 oxygen, you're going to get a molar mass. Then. So 1 mole of this compound, okay, it's going to be equal to 75 grams of that compound. That is our molar mass that you have to be able to use for this conversion here. Okay? So it is absolutely important, folks, that you go and you memorize the polyatomic ions. Make sure you review how to come up with the names and the formulas for these compounds as well, because the molar mass of a compound requires that you get the correct formula. And why do you need the correct formula? Because you need to be able to get the correct ratio of the atoms, add them together. Okay. So again, if you don't remember that, go back and review that in chapter 10. And you come by and you see me, or you ask about it on Thursday. Okay. All right. So plugging it in, then you have 1 mole of NaClO on the top, and 75 grams of NaClO on the bottom. Plugging it in, doing our math, we then end with an answer of 9.28 times 10 to the minus 1 moles of sodium hypochlorite. So make sure you review that. Okay. All right. Going a little bit over. Let me just go ahead and do the last one here. For the last one, then we start out with what the given amount is 4.27 times 10 to the 24th. And here we're given molecules of carbon monoxide. We're given the actual number of carbon monoxide molecules. Okay? And we're going to solve then for the moles. That's what we're going to solve for of carbon monoxide. Here then we're going to use the Avogadro's number, okay, which is our conversion factor here. Tells us then that we have 1 mole of carbon monoxide can be equal to 6.02 times 10 to the 23rd particles of carbon monoxide. Okay, this is just the definition, the basic definition of the mole. Okay, and so this is the conversion. This is the relationship that we're going to use to plug in for our conversion factor. We'll plug it in so that it's 1 mole of CO on the top, 6.02 times 10 to the 23rd carbon monoxide molecules on the bottom. That allows us to cancel this out. Make sure you can punch these numbers into your calculator using that EE function, folks. And if you do that, you get your answer then as 7.09 moles of carbon monoxide. And the check that you can use here then is that if you notice here, we have a lot more. 10 to the 24th is bigger than 10 to the 23rd. We have more particles here, then that means then the number of moles that we get should be bigger than 1 here. Okay. All right. So, well, we spent we spent this period then reviewing what you should know in chapter 10. So make sure you write this down. Make sure you have this available for you to help you review. Okay. Take a look at what we have here. Take a look at number 4. Okay. Make sure you submit this for your to finish up the assignment for the lecture today. But look at it. Use it to also use it to also kind of situate yourself and make sure you use it to help you review, and also to figure out then what you need, what you do know, what you don't need, what you do know, and what you don't know. And what you don't know, folks, make sure you come by and you see me either today after school, or you stop by, or you ask the question on Thursday when we review for the exam. Okay. All right. So make sure you take a look at this, folks. Make sure you take a look at slowly review. Don't try to cram it in on the last day. Okay. And then bring your questions and we'll get those in. Okay. All right, very good. So I will see you folks tomorrow. So remember, tomorrow we're meeting live. Okay, so I'll at 12:05. Please make sure you check in with Zoom. I'll post the login information for you on Classroom. So make sure you use that, and we'll meet live tomorrow at 12:05. So I look forward to seeing you folks then. Okay, have a good day, folks.